Next, let us get into the problems on heat equation. So here also you will be having an equation dou u by dou t equal to c square dou square u by dou x square, subject to the conditions u of 0 comma t is 0, u of l comma t is 0, and u of x comma 0 equal to f of x. So here you have first two conditions will be same. For any problem, the first two conditions will be same. U of 0 comma t is 0 and u of l comma t. The last condition you have to use after simplifying. So here this is the general solution, u of x comma t e power minus c square p square t into a cos px plus b sin px. Call it as 1. I am using first condition. When x is 0, whole term is 0. When x is 0, u is 0. So ending with 0 equal to e power minus c square p square t into a. Here when two products are 0, each term is 0. If this term only becomes 0, 0 into anything 0, u of x comma t will be 0, which is not possible. So we must have a 0. So putting a 0 here, you get u of x comma t as this term. I am using the next condition. When x is L, u is 0. So 0 equal to this term. Again, since a is 0, b cannot be 0, because if both a and b 0, the whole term vanishes. So b cannot be 0. We must have sin pl 0. If sin pl is 0, sin pl is sin n pi, pl is n pi, so p is n pi by l. So using this condition in the main equation, I end up with u of x comma t as e to the power of minus c square n square pi square t square by l square b sin n pi x by l. Because we have n, I am generalizing it for summation u of x comma t as summation n varies from 1 to infinity bn e power minus c square n square pi square t square by l square into sin n pi x by l. Now I am using the last condition, that is u of x comma 0 is f of x. That is when t is 0, u is f of x. You end up with f of x as summation n varies from 1 to infinity bn sin n pi x by l. So for any problem you end up with this result followed by u of x comma t. So finally u of x comma t will be summation n varies from 1 to infinity bn sin n pi x by l multiplied by e to the power of minus c square n square pi square t square by l square. So this is the idea. So any problem given, you have to do starting from here to here. So it is given in the notes also, application notes, which I have shared. There also you can go through. So keeping this in mind, I will take one problem. Already we did one problem, so another problem I am taking. The same conditions, but the last condition is different. So I am ending up with this, like you have to do the same derivations till here, and you have to take that equation, put t 0, you end up with this. This is nothing but half range sine series. Use the last condition. When t is 0, this is the condition. So you end up with this, which is nothing but half range. You know bn 2 by l 0 to l f of x into sin n pi x by l. F of x is 100x by l. So it is nothing but bn is 2 by l square, because bn is already f of x 100x by l. X into sin n pi x by l, which is Bernoulli's rule. We get bn as this term. We substitute bn in the equation. You end up with u of x comma t as this term. So any problem given in heat equation, the first two conditions will be same, and you end up with this result, and you should use the last condition here to get the final result. So there is another problem where you have two different functions. Here also same, the first two conditions are same, last condition is different. So I am using the last condition. It is a split function, because 0 to l by 2 first function, l by 2 to l second function. Then I have took common. Again I have applied Bernoulli's rule. I get Bn as this term. I resubstitute Bn in the main problem and I am writing u of x comma t as this result. So any problem in wave or heat, the first conditions will be same and you will derive the u of x comma t, and at last you are using the last condition to obtain the solution for the problem.